Okay, so with this problem, we are working with Chapter 5, Section 3, and we're just talking about polynomials. So the first thing is we need to identify the degree of a polynomial. And the main thing is we only care for degrees. We care about the sum of the exponents of all the variables, So it's sort of like ignore the coefficient or ignore the number that's in front. And all we care about is where our variables are and the exponent of those variables. So the degree of this monomial, by the way, these are called monomials when they're just one term. So this degree is 2. Sometimes we call it a quadratic. You probably remember that from Algebra 2. You can just say the degree is 2. And then as I move on to letter B, this is to the 5th power. Again, ignore this other stuff. I probably shouldn't cross it off, but we only care about the variables. And when it's a 5th degree, you might hear us call it a quintic, or you can write out the degree is 5. I just like the fancy word, but you can give me the other as well. So again, as we look at the next one, there's only one variable. It's y this time, but it's to the 1st power. Sometimes we call it a linear, but the degree is just 1. So linear, think of y equals mx plus b. It makes a straight line if you were to graph that. I guess technically it'd be y equals 0 there, but you can just give me degree of 1. And if you check with the back of the book, I'm sure it just gives you the numerical value. So again, we ignore the 12 in letter D. We look at the x, the y, and the z. We look at all of those, and we add those degrees together. So this degree is 4, and for the fancy word, it's quartic. 4th degree polynomial is called a quartic. 4 quarters make $1. It's easy to remember. 4 quarts make a gallon. Now notice in this one, there's no variable. So the degree in this problem when there's no variable is 0. Okay, we don't really have a fancy name for this, so that might be another reason why we just say degree is 0. There's no variable, so that's why we have that. All right, so now as we look at these things, the first thing I want to establish is if it's a monomial, a binomial, or a trinomial. So the way we name our polynomials is the number of terms. Well, terms are separated by plus or minus signs. Are separated by plus or minus. I've also seen math teachers explain this as saying one term only uses multiplication or division and has numbers, and variables, and things like that. So as you look at A, B, and C, the only one that this is a negative sign right here, so that's what I was trying to get at, is that this is a monomial for letter B. Whereas if you look at, there's 1 minus there, there's 1 plus. So this letter A, because of the 2 plus or minus signs, it's separated into 3 terms. The prefix tri means 3, so 3 terms. Whereas as you look over here, there's only 1, so there are 2 terms, which, like a bicycle, we call that a binomial. There's 2 terms. Bikes have 2 wheels. So now let's talk about the degree. With the degree, we only look at each term individually. So the first term in this trinomial has a degree of 3. This term has a degree of 1. And this term has a degree of 0. And what we do is we look at the highest degree of each term. And we only consider this by its highest degree of each term. So because the highest term in letter A is 3, then we say it's a 3rd degree polynomial, and sometimes we use the word we use cubic. So you will hear me say it's a cubic trinomial because the highest exponent was 3. So as you look at letter B, there's only one term to look at, and the sum of those degrees is 3. So again, this is a cubic monomial. I'll write it right here. So as you look at letter C, there's only 2 terms to look at. One is to the 4th power. This degree is 0, so between the two of them, the highest one is 4th. And remember, I like to call that a quartic. So this is a quartic binomial. So now let's look at the degree of exercise 3. Well, as you look at it, the first term, the degree is 4. The second term, 3 plus 2 is 5. The third term, the degree is 5. And the fourth term, the degree is 0. So looking at all 4 of those terms, the highest one is 5. And it doesn't matter if you look at that 5 or that 5. So this degree is 5. Or in other words, it's a quintic. And I will accept both answers. So you choose. So on the next problem is getting you to practice function notation, and I think the main point of this is to remind you that in function notation you put -1 in for all the x's, and you can use a calculator, but I want to point out that -1 when you square it becomes +1 times that -5. So -5 minus 2 is -7 minus 8 is -15. All right, and then just change colors. This next one's the same thing. Just make sure you square before you multiply. Again, I'm plugging 3 in for all those x's. So 3 squared is 9 times -5 is -45 plus 6 minus 8. Well, -45 minus 2 will give me -47. So as we'll look at exercise 5, again, feel free to pause it if you need to try these on your own and reread the problem, make sure you understand it. So basically we are dropping an object off of a bridge, and this is the equation that they came up with. So the first part is find the height of the object at 0 seconds. Well, if you plug in 0 for this t, well, 0 squared is still 0. 0 times anything is 0 plus 290. So p of 0 will give me 290. You don't have to give me units, but if you reread the problem, the height is given in feet. So now let's plug in 2 into the problem. Now I'm just going to go to a calculator, but 2 squared is 4. -16 times 4 is -64, and when I add 290 to it, I get 226. So P of 2 is equal to 226 feet. So now what we can do is approximate to the nearest second when the object hits the ground. Well, what needs to happen if the object hits the ground is that the height needs to be 0. So what I'm going to do is I'm going to take that equation and set it equal to 0. So all I need to do is subtract 290 over. And then divide by 290 divided by 16. Negative over negative is positive. So t squared is about 18.125. And because we're rounding to the nearest second, I know you know me by now, I like to round to 3 decimal places. Even though the directions just say, it's still going to round to 3 decimal places. So when I square root that, 4.257 seconds. So the nearest second would be just 4 seconds. And then that kind of answers the next question to the nearest tenth of a second. It's going to be the same answer, 4.3. So I'm going to move on. So feel free to pause the video and make sure you understand how to do this on your own. So as we move on to the next, we're combining like terms. So remember, like terms has to have the same variable and exponent. So as I work through this, the only ones I can combine together are 8x to the fourth minus 5x to the fourth. So that's 3x to the fourth. And I cannot combine that with that minus 5x. So looking at the next one, we have AB. 4 plus 3 is 7AB. But you're still not done because now you have a negative 5b plus 2b. So that would be negative 3b. That's all I want you to do. So now then exercise 7, combining like terms, even though it doesn't say it, just add. Well, 5x cubed plus 1x cubed, that is 6x cubes. Negative 3x squared plus 9x squared. Notice the sign in front is stuck to it. So negative 3 plus 9 is 12. Let's see, I haven't used this. Negative 9x plus 2x, same variable, same exponent, that's negative 7x. And there's nothing like with that minus 8. There we go, so we're done with that. And we have some more adding going on. Notice that there's not a like term with this 3a to the fourth b. Yes, there's a's and b's, but they're not the same exact exponents. So I cannot change that. But now I can change minus 5ab squared plus 9ab squared. Negative 5 plus 9 is 4ab squared. And then 7 plus negative 12. They are like terms because even though they don't have variables, that's what they have in common, that they have the same no variables. So 7 minus 12 gives me negative 5. That's it for that one. Same thing on letter B, that 2x to the fifth doesn't have anybody to combine like terms with. I can combine minus 3y with plus 4y though, that's plus 1y. You don't have to write the 1 in front. 1x minus 2x is negative 1x. Again, I don't have to write that. Negative 6 and negative 3 is negative 9. So there's an answer to letter B. And just to finish this, I like to explain number 9 a little bit differently than other teachers. I like to go ahead and distribute that minus in there. Sometimes I also combine things together, like I'll actually move pieces together, like moving that 3z to the fourth in front. But that's not like terms of that z. Negative 12z, this becomes a minus 1z cubed. Again, you have to distribute. And then plus z, and then minus 12z. So I hope you're okay that I move things around. Now I can combine things together. So nothing to combine with that 12z to the fifth or 3z to the fourth. But these two I can put together to give me negative 13z to the third. And 1z minus 12z is negative 11z. And there's that answer. Now be careful with this last one because the order does matter. The way they phrase it is it's actually 11x squared y squared minus 7xy squared minus the quantity of 5x squared y squared minus 3. Because the English language is confusing, when you say subtract something from something, you're actually flipping the order around. But again, notice how I'm distributing that minus in there. So 11 minus 5 is 6. Negative 7 minus negative 3 is really negative 7 plus 3, which is negative 4. And then distributing that minus just makes it minus 5y cubed. All right. I'm skipping example 11 and 12. Here's your homework.